All right, guys, this time we're going to look at reteaching 9-4 on the A side down at the bottom, and we're going to compare two situations where one is independent and one is dependent when we're dealing with compound event probability. So we're going to have the letters in the word Massachusetts. There are a total of 13 letters here, and they're written on a card, and the cards are then placed into a basket. We want to find each of these probabilities. For number 5, it asks us what's the probability of selecting two S's if the first card is replaced before selecting the second card. Now, since we replaced that first card before we make our second pick, we're resetting the situation. So these two events are not dependent on each other. They're independent. What happens first does not change what can happen second. So we're going to just multiply the probability of each pick together. So we want the probability of selecting S on the first pick. Then we reset the situation. We have all the same letters again, and we're going to multiply that by the probability of getting S for that second pick. So if you look at the word Massachusetts, we have 1, 2, 3, 4 S's out of our total of 13 letters. So on our first pick, we have a 4 in 13 shot of getting an S. Then we picked our S, we put it back, replaced it. So then on our second pick, we're going to have a 4 in 13 shot of getting an S again. And to get the probability of both those things happening, we multiply them together and get that our chance would be 16 out of 169. In problem 6, the situation changes slightly. It asks, what is the probability of selecting two S's if the first card is not replaced before selecting the second card? So now the situation changes based on what happens first. So it depends what happens first, what we have available to happen second. So this is a pair of dependent events. When that happens, we're still going to multiply the two probabilities, but something changes. So on our first pick, we need the probability of getting an S. Then we're going to multiply that by the probability of getting an S on our second pick, but assuming that we've gotten what we wanted the first time. So we write that as the probability of getting an S after we've already gotten one of the S's. So on the first pick, we have a 4 in 13 shot, just like we did before in problem 5. But on our second pick, we're going to assume we've picked one of these S's. So I'm going to cross it out here and look at what's left. So our chance of getting an S now, there are only 3 remaining S's, and there aren't 13 cards to pick from anymore. Now there's only 12. So now we can multiply these two probabilities together. This one we can do a little simplifying as well. If you multiply it all together first, you're going to get 12 over 156. And then to simplify, your final answer would end up being 1 out of 13. So this would be your probability of getting an S, two S's when you do not replace the cards.